Hello, I'm looking at the UMaine portal. This would be our start point. We're going to select Google Drive. I've already opened my Google Drive, and I made a folder for the class. I'm pretending to be a student in this video, so I'm just going to narrate what a student would do for this homework. This will be a pretty complete video tutorial for this homework because we're building some new tech skills. The assumption is that as we go along here, these tech skills will build on themselves and help you to analyze more challenging questions about data. So let's go to New and make a new Google Sheets. And I'm going to call that just Homework 1, whenever it catches up with me. So Homework 1. And I've shared with you some data. So go ahead and copy that data however you like, and then paste it in your new spreadsheet. And so the first thing we're going to do is make a graph. So go ahead and Insert, Chart, and we do not want the default graph. We do not want a line chart. So go under the chart editor to line chart, and we're going to scroll down and find a scatter plot. And then we're going to customize this chart. We're going to go to Chart and Axis Titles. We'll change the chart title to Atmospheric CO2 concentrations at Mauna Loa. And you can play with it if you want. I like to center it. Now we can change axis titles. The horizontal axis is in years, and the vertical axis would be concentration in ppm, or parts per million. If you're ever not sure about this, I will always be including links to the original data, so you can just visit the link I had given you, and you'll see it's parts per million on the side. So now I have a chart. I want to show you how to get that into a homework. So go to the folder, or wherever you're keeping this. Folders are nice for organizing things, of course. And click on New, click on Google Docs. Now if you want to do this in Pages or whatever, or Word or OpenOffice, those are all fine. I'm always going to instruct from Google Docs because it's something that everyone has equal access to. But feel free to use whatever software you prefer. And let's make sure this makes sense. So MAT103, whatever time your section is, maybe Homework 1, and put your name on there. Okay, so this is what we're going to print off eventually and pass in. Go to Insert, go to Chart, and then down here from Sheets will allow us to select a sheet like Homework 1. You double click if you want. And then this is a chart in there, so we can import and leave this link to spreadsheet. This will be handy. So now I have my graph of the data. But what would it ask you to do in homework? Make a labeled graph, and then to create a linear model and other things too. And your homework should include 2 graphs, one for each model. So let's go back and make a linear model. The way we do that, if we go to Series, so under Chart Editor, go to Series, and there'll be a box trend line. This is spreadsheet language for adding an equation that matches the data. So it defaults to linear, and if we scroll down, there'll be an option under Label, None. But we don't want none, we would like to see the equation. So there it is. Now I've done some stuff to this graph. If I go back to the doc, you'll notice that in a moment, a little button shows up, Update. I can click that, and it There we go. It's working very slowly. It should have the equation on here. I don't know why it doesn't. Oh, good grief. This is the... Oh, come on. Here we go. Try again. There we go. So there's the equation. Let's talk about that equation just briefly. You're not asked too many questions about it, but this is good practice because we'll be spending lots of time in this class on these things. Your equation is something like this. I'm going to put some letters in there. I don't like using y and x because this isn't about y's or x's. So CO2 is being modeled by a linear equation here in relation to years. As years go by, CO2 changes. This is the prediction. And this 1.54 is the linear rate of change. It would be ppm per year. And this negative 2,702 would have units of ppm. That's the vertical intercept. Now this is an artifact of the model. It says that at year 0, concentrations are negative. They weren't. Models are not good for all time, all places, everywhere. They have some range of applicability. This model, it doesn't make sense to go back this far. So you can't take these too literally. But this model does a pretty good job of describing some of the data. You can decide what you think of the fit. It's not bad in the middle. It's a little off in the beginning and the end of our data set. That's interesting. So that was one thing you were asked to do. The next thing was to create an exponential model. So let me show you an easy way of doing that. If you go down here to sheet 1, that's where we are, click the menu, click copy, and then that's my 103 folder. There's my spreadsheet. So when I copy this sheet within the spreadsheet, and you'll see there's a new sheet, copy of sheet 1. So I can do things like rename these, linear, and then I can go to sheet 2 and rename exponential. And I have everything I've done so far from the previous sheet. Now let's go ahead and edit the chart. That same chart editor comes up. Go to Customize. Go to Series. Trend line is already selected, but we want to change from linear to exponential. And we're going to go ahead and import this into our document, and we'll talk about what this means up here. So let's go to Insert, Chart, from Sheets, Homework 1. Now I have two choices. I already have the first one. Let's grab the second one. Where are you? Now what does this equation mean this time? Well, I see this decimal, 0.0601. It's times some letter E. I want a superscript because that's a power coming up. You see the little caret. So what does this mean? You probably have seen this on your calculator before. So I'll tell you what it means. So let me get some more space here. So 4.36e to negative 03 means that negative 3, that e negative 3 means move the decimal point to the left 3 times. So it'll be 0.00436. It's scientific notation. So the equation actually reads something more like CO2 equals 0.0601 times, let's do times, E raised to the power of, I'm just using keyboard shortcuts, it'd be 0.00436. I'm going to put a T in there because, again, there are no X's here. We're not selling xylophones. So I want to use letters that describe my variables. Now you may not be familiar with what this letter E stands for. So there's a lot of cool things your browser does that you may or may not be aware of. If I open a tab and write E equals, there's E equals MC squared. That's cute. But there's a built-in calculator into Chrome, and it'll give you this number, and this is what E is. E is a number like pi. It's transcendental. It's a fancy thing. And so I have that number. So if I want, I can do something like CO2 equals 0.0601 times. I'm going to use some parentheses here to be careful. And then do an exponent, 0.00436 times t. This is my equation. Now I can use this to predict the future. I can use both of my models to predict the future. Let's go to the linear model. All right. So up here, if I want to predict what this gives me in 2025, it's 1.54 2025 minus 2,702. You can compute that. Again, you can just do it even right within your browser. If you go up, take a tab, you can just put it right in the search field and compute right from there. The other one, the exponential equation, this one will take a little bit of work. What you'll notice is if you grab this, and I'll walk you through this one a bit better. If I put it in here, it's not going to come out right. All these numbers get blurred together. What we need to have here is a little caret. That is Shift 6. And then I want some parentheses. One of the things that we'll run into constantly is order of operations. Computers and calculators only do exactly and literally what we tell them to do. They don't read into our intentions. So here I have that 0.06 number. This number here is E. You want as much of this as possible. If you round this, I'll show you what happens when you round it. You get pretty different answers. Raised to the power of that 436 number. Now I don't want T, of course. I want 2025. So I'm showing you this answer so that you get the same answer. So if you don't get this answer, you can check your syntax. Now what happens if somebody says, I'm not going to use all those numbers, I'll just use 2.7? Well, now you're off by, 24. So that's pretty significant. If I put a 1 back in there, now I'm a little closer. If I put an 8 back in there, this is one of the things we'll see with exponential equations. It's very sensitive. This is in the thousandths place, but it's still significantly altering this number here. It's pretty tricky. So anyway, back to our homework. So you can do a prediction here. How are we doing here? Let's see. So an opinion. And now let's look at this here. I have about a minute left. My software allows 15-minute videos. Oops. Let's see. IPPC scenarios CO2. I'll just find it. So the point in this bit here is oh, hold on a second. Let me pause this. All right. So I follow the link. This is the page it brings you to. The point of this is if you scroll down, if you take a minute, you'll see this graph. And the little table of acronyms up here correspond to these different models. And let's see, where is it? It's if you click on any one of these, let's just open a new tab. It'll bring you to a page where it describes those different models. So basically the idea is that scientists, using the best technology, data, and mathematics we have a range of possible predictions for CO2 levels. They're all higher than present, and it depends upon the particular path the world takes. And so I'm just asking you to comment on these.